All right, so here we're going to look at finding some power series from known power series, right? So in the previous video, we started by going over the Maclaurin series for the cosine of x, and then here we have a table of just these common functions, right, which we'll use to kind of help us, right, evaluate series when necessary, or find what the function is representing here, or just create a new power series from these known ones here. All right, so for example, let's say I want to find the Maclaurin series for f of x equals to sine of x squared. All right, so here looking at this, right, that's my sine function here. So when it comes to sine of x squared, I just take the x and replace it with x squared. Right, so for something like this, right, the sine of x squared would look like to infinity, -1 to the n, x squared raised to the 2n plus 1 over 2n plus 1 factorial. Okay, and then just simplifying this, this is -1 to the n equals 0 to infinity, x to the 4n plus 2 over 2n plus 1 factorial. Right, and just writing out a few terms of that, it looks like this when n is 0, right? We get x squared over 1 factorial, alternating, so when it's 1, x to the 6 over 3 factorial, right? All the odd terms, x to the 10th over 5 factorial minus x to the 14th over 7 factorial, etc. Okay, so that's how we create a new series from one that is already known here. All right, let's try another one here. Right? So let's say that, again, same premise, right? Use a known Maclaurin series to find a Maclaurin series for f of x equals to x squared over square root of 2 plus x. All right, so at this point, what it comes down to is really just kind of pattern matching here. Looking at this, right, at these known functions, right, maybe it's 1 over 1 minus x, but that power tells me it's probably a binomial here. So let's take a look here what I can do with my function. So first I'll use the exponent notation for the root. Okay. And then here I'm going to factor out a 2. So we get x squared. And then I'll use, right, 2 to the 1/2, 1 plus x over 2, all of that to the 1/2. Okay. All right, so now we can here rewrite this All right, so it looks like I have a binomial where r is -1/2, right? So now I can write my f of x here to be x squared over root 2. All right, again, just write it outside the sum notation, so it doesn't depend on n, right? So n goes from 0 to infinity of -1/2, choose n. And we get x over 2 to the n power. All right. And then just to get an idea of what this looks like here, we have x squared over root 2. Then 0, so that's always 1. And then plus negative 1/2 over 1 factorial x over 2 to the first power, right? Plus negative 1/2 times negative 3/2, right? Over 2 factorial, right? I've already subtracted the 1 there, over x over 2 squared, plus negative 1/2, negative 3/2, negative 5/2, all over 3 factorial, x over 2 cubed. All right, now a couple things that I notice here. All right, so here, notice that it's going to be alternating, right? Here there's 1 negative, so this will be minus. 2 negative, that stays plus. 3 negative, that also stays plus there. Excuse me, stays negative. All right, so it alternates plus minus here, right? Another thing to notice is the power, right, matches up with the number of powers of 2 here, but those are equivalent also down here, right? So there's 2 squared here and 2 squared here, and they're both in the denominator, right? The fraction there. All right, so I'm just pointing that out because we have we want to kind of simplify the way we write it in the sigma notation here. Right, so one thing we can do here is we can rewrite this in a different manner, right? Again, still the same power series here, where it'll be x2 over root 2, right? 1 plus the sum. We start at 1 to infinity, and alternating, first one being negative, and in the top, right, we don't quite have factorials in the top, right? It's all the odd numbers, right? 1, 1, 3, 1, 3, 5, etc. So it'll be 1 times 3 times 5 to whatever the nth 2n minus 1 odd number is. On the bottom, we have the n factorial, right? 1, 2, 3, etc. And then powers of 2 that are 2n, right? The 2n comes from, here are the powers, and then there's 2 more here. There's 3 here, and then there's 3 more here. Okay, so that's where the 2n comes from, and then times x to the n. Okay, so it looks something like this. All right, and we can distribute the x squared and root 2 if we want. I'll just leave it like this here. And in terms of the radius of convergence, so here, oops, excuse, yeah, that's good. The radius of convergence would be the x over 2 less than 1, or absolute value of x less than 2. So we have a radius of 2, right? And my inner row of convergence is just the absolute value of x less than 2, right? So that's how we can do, so that's what we do to manipulate, right, known Maclaurin series to come up with new Maclaurin series.